Good morning, boys and girls. Welcome to the grade 12 extra class math holiday program. Every single day this holiday I'm going to try and upload a short video for you to do some revision on the first term work that you've already done, but also then work through some of the term 2 and 3 topics, which are the more challenging and the more weighing in the papers topics, the topics that weigh more. So I'm going to look at some topics starting today with trigonometry part 1. I also have this classes that I present here on YouTube in a quick lesson. I will have an hour lesson every single day, a live video class on Skype that you can attend, and we'll do the same topic that I do on the YouTube channel, but the lesson is more extensive. It will have an explanation, and then also I'll also work through some question papers, and then I'll also answer some questions that you might have there. So you can attend the class, you can ask me questions, and then I'll answer those for you as well. And if you attend the classes, you also have access to my WhatsApp number that you can send me messages as you're working through your work in the morning. If you have any queries and questions, then you can send me a message, and I'll just answer you or assist you as best as I can. These online classes, the live classes, they are paid for, but if you're interested in attending those classes, I think it will be really beneficial for most of you, especially since we are now in crisis mode with the coronavirus in the country. You can just send me an email. There is my email address, neriventer08@gmail.com. Just check the spelling of my name. Okay, so let's look at trigonometry part 1 today. Right, the lesson today we are just going to revise through the grade 11 work quickly. Most of you will know most of this, but if there's grade 11 work that you missed somewhere along the line, or you're not 100% sure of, then it really makes the grade 12 trigonometry quite challenging, because the grade 12 trigonometry, you must now, you know this, you are doing the double and the compound angle formulas, and you are incorporating them into all of the grade 11 trigonometry. So if there's gaps in the knowledge with grade 11 trigonometry, it really is a challenge, right? So I'm quickly going to just briefly look at 3 things. The first thing is the cast diagram. The cast diagram, you should know this very well by now, goes 0, 90, 180 to 73, 60. You can see I go bigger in this direction, and then if I look at 360 to 70, I go smaller in this direction. So my angle theta normally lies in quadrant 1. To place this angle in different quadrants, if I use the plus, I can use 90 plus theta to place it in quadrant 2, 180 plus theta to place it in quadrant 3. You see I go this direction for plus. 270 plus theta, that direction will lie it in quadrant 4, and 360 plus theta will lie it in quadrant 1 again. And then if I go the minus direction, 0 or 360 minus theta will be placed in quadrant 4. This is quite important. We know 360 minus theta in quadrant 4, but whenever we get negative angles, we do all sorts of weird things with them. It's good to know that negative theta is 0 minus theta, which just like 360 minus theta just simply lies in quadrant 4. You treat it like that. 270 minus theta lies in quadrant 3. 180 minus theta lies in quadrant 2. 90 minus theta, quadrant 1. And then you should know that at 90 and 270, if I use 90 minus or plus, 270 minus or plus, then I'm using actually the co-functions, which means I'm going to change from sine to cosine and cosine to sine. That's all one that's in your syllabus. But just so you know, the tan, sec, cosec and cot, they also change into something else here. So be careful when using these ones. These ones, 0, 360 and 180, when I use theta, 180 minus theta, sine of 180 minus theta is just sine theta. Sine of 180 plus theta is going to be negative sine theta, because sine is positive there. And negative there. How I did that, or how I know that, is by just writing the letters cast there in quadrant 4, 1, 2 and 3. In quadrant 4 cos is positive, the other one sine, tan negative. In quadrant 1 all is positive, 2 sine and 3 tan is positive. I think most of you knows this. Let's quickly look at an example of using reductions to simplify. So if I have, for instance, tan minus 60, cos minus 156, cos 294 over sine 492, just a heads up, I did take this example from a grade 12 textbook, so it is possible that we might encounter the double and compound angles formulas in this question. So if we see that, just, I think most, yeah, if you are a grade 11 watching this, don't worry about it. If you are a grade 12 watching this, we've already looked at that in classes during the first term, so you should be fine, but we're focusing on the reductions for the moment. So tan minus 60, as I've said, minus 0 minus 60 will lie in quadrant 4, where tan is negative, so I can change this into negative tan 60. Right, ooh, that's a very horrible line. And then 156 lies between 90 and 180. I'm rather going to stick to 180, 360 plus and minus as far as I possibly can. 156 lies between 90 and 180, so I'm going to use 180 minus theta to write that angle. 180 minus, and now I must just think 180 minus what will give me that 156, which is then 24 degrees, and 294 I see lies between 270 and 360, so I'm also rather going to put that as 360 minus something, 360 minus 66. If you need to use your calculator to get these values, that's fine. 492, you can always add and subtract 360 as many times as you like from an angle without changing it, because say for instance I have an angle that lies there. If I add 360 degrees to it, it's just going to come back to where it was. If I subtract 360, it's just going to come back to where it was. So 492, I can subtract 360, and then it's 132, which lies between 90 and 180, and I'm going to write that as 180 minus 48. Then 48, yeah, I already see the double angle coming along there nicely, so we're probably going to use that. And then for 60, I'm going to use special angles. You might have a method for special angles that you work with. I'm just going to quickly go through my method for special angles with you. If you don't have a method, some of us use those triangles, some of us use the circle, some of us use the table, some of you might know the hand. I use the hand method, but whatever method you use, that's fine. If you don't have a method per se, you can quickly look at my method and then use that. I'm just briefly going to explain through it, but I think most of us has a method for doing special angles. So what I do, I have 0, 30, 45, 60 and 90 degrees on each finger of a hand, and I can nicely see there that that's a 90 degree angle, you see, and that makes roughly a 30 degree, roughly a 45 degree, so it's a nice visual for me as well. So I have there the angles, and then on the fingers I'm going to number from 0 to 4 and 0 to 4, but I take the square roots of these numbers. So the square root of 0, the square root of 1, the square root of 2, the square root of 3, and the square root of 4, which is 2, and then the square root of 0, 1, 2, 3, and 4. Right, this I must know out of my head. The far side, if I look at the hand, the far side numbers are the opposites, and the closer numbers are the adjacents. So these are my opposite numbers, these are my adjacent numbers, and then for the hand you can always use your hypotenuse as 2. So you know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So then to read special angles from here, these are my opposite, these are my adjacent, and my hypotenuse is 2. So for instance, tan 60, which is negative tan 60 now currently, I look at the 60 finger, I know tan is opposite over adjacent, so I'm going to take the opposite, which is then at 60, it's root 3 over the adjacent, which is 1. So root 3 over 1, which is just root 3. This camera is quite blurry. I don't know if you can see there properly, so I'm just quickly going to hold it closer. Yeah, so there you can see I'm going to use the opposite, root 3 over the adjacent 1 for 60. If I have to find, for instance, sine 30, sine is must now opposite over hypotenuse, so I'm going to look at the 30 finger. The opposite is 1 over hypotenuse is 2, so 1 over 2. If I want to find cos of 90, cos is adjacent over hypotenuse, so I look at the 90 finger, adjacent is 0 over hypotenuse is 2, so 0 over 2. So cos of 90 is 0. Right, so that's how I do that. I'm just going to see if I can't maybe just put this camera a little bit closer to the paper, because I feel like it's a little bit unreadable. Okay, alright, I think that's better. Right, so I have there negative root 3 cos minus 180. This is now quadrant 180 minus lies in quadrant 2, so this is cos in quadrant 2, which is going to be negative cos 24. 360 minus 66, this is 360 minus theta, typically a quadrant in quadrant 4 where cos is positive, so this is positive cos 66, and then 180 minus 48, which is quadrant 2 where sine is positive, so I have sine 48. Right, now I see there 24 and 48 double angles of one another, so I'm already thinking I must probably make this a double angle something. Cos 24 sine 24, maybe. Does sine 24 and 66, 24 and 66 does actually give me 24 and 66 does actually give me 90, so I can use my 90 minus formula there to make that one sine 24, and then you see the sine 24 cos 24 looks like the double angle formula. I'm just going to multiply the negative with the negative, then I have sine 24 cos 24, because I can make cos 66, I can make it sine 24. It's a co-function. I didn't write the steps here, but cos 66 is must now cos 90 minus 24, which is equal to sine 24. I just made it sine 24, and then the negative times the negative is positive, the root 3 is there, the cos 24 is there over sine 48. And now this looks like the double angle formula, but I need a 2 there. Now I can put the 2 there as long as I just put it on the top and the bottom. It's like multiplying with 1. So if I multiply this equation with 2 over 2, it stays the same. The reason why I would do that is just to get the 2 there, because this looks like the double angle formula for sine. So now this becomes root 3 over and 2 sine 24 cos 24 is most now going to be sine 48 by using the grade 12 double angle formulas. Don't worry too much about it, we'll look at that tomorrow. And then that will cancel, leaving me root 3 over 2. Alright, so that is using reductions. I think for this lesson just focus on what I do with the reductions. Don't stress too much about how I manipulate it with the grade 12 formulas. We'll look at that tomorrow as well. Alright, so that's reductions, special angles, which is already a big part of grade 11 trigonometry. Then we also have the cast diagram problems where you have to go put the triangle in the specific quadrant, something like if sine theta is 2 over 3 and theta lies between 0 and 360 or between 90 and 270, whatever. Find without the calculator the value of sine 24 or cos 24, the cast diagram problems where you go draw the triangle. There's two versions of that. You can either just quickly turn over this page here. Right, okay, so you can either have something like that if sine theta is 2 over 3 and theta lies, say for instance, between 90 and 270. Find the value of cos theta or whatever, this type of problem where you have to go and decide. I think most of you know very well how this works. But we are going to incorporate into the grade 12 work also this type of question. So I just want to quickly mention this. So I'm looking at sine which is positive between 90 and 270, meaning I'm working in quadrant 2 because sine is positive there and negative there between 90 and 270. If sine is positive, I'll work there. And then sine is must now opposite over hypotenuse 2 over 3. I can work out that missing side using Pythagoras, and then I can just read my cos. Just notice it's going to be negative because it's on the negative x-axis, and then I can read whatever questions A, B, C they ask me here. I can read from this triangle. So cos will be that over 3. Whatever they ask me, I read from the triangle. Another type of this question that they do ask, if sine 23 is p, write in terms of p. Write in terms of p. They do like asking this in grade 12. So they give you a 23, which means you have a triangle in quadrant 1, obviously, because it's between 0 and 90, and then the p, you can just put it over 1, so sine is opposite over hypotenuse. You can work out that missing side with Pythagoras. It's going to be 1 minus p squared, like that. You can show your work Pythagoras, and then say for instance I must now say what is cos 23. I can read that from the graph, so it will be this root over 1, which is just this root. Or say for instance what is sine 203. Then you see this is including a reduction and this question, so then I must first just do the reduction. 203 lies between, let's quickly look there, 203 lies between 180 and 270, so I'm going to write that as 180 plus 180 plus theta, and 180 plus 23 will give me 203, and then this is sine in quadrant 3, which is going to be negative sine 23, and then I can read my sine, well, sine is p, so negative p, or I can read, if it was cos or tan, I can read it from this diagram. What I'm trying to ultimately do here and there is I draw my triangle, and then whatever they ask me here, I try to to rework it to theta so that I can read it from my triangle, which has an angle theta, or in this case, whatever they give me here, I'm trying to rework it to get to 23 so that I can read my answer from my triangle there. If they give me 203, I'm trying to write it as something in terms of 23. If they give me tan 293, you see 293 lies between 270 and 360, but 360 minus 67 will give me 293, which 67 is not on my sketch. That's not ideal. So then I can try maybe writing this as 270 plus 23, which gives me 293. You see, the aim of the game here is to get the angle to 23. So in this case, 360 minus won't work. I'm going to then look at 270 plus in grade 12. But now you see you don't know what to do with tan at 270. So you can change this into sine 270 plus 23 over cos 270 plus 23, and then at 270 I change from sine to cos. This is quadrant 4, so sine is negative there, negative cos 23, and cos 270 plus 23 is going to change to positive sine, because cos in quadrant 4 is positive. Even though I change it to sine, I follow the signage of the one it was, the original. So sine 23, and then this is cos over sine, which you see as the reverse of tan, so negative cot 23. If you are comfortable with that, or you can write this as negative 1 over tan, or you can read the cos 23 over sine 23 from that sketch and substitute and simplify. It's just faster to notice that sine over cos is tan, so cos over sine is going to be cot, which is then, instead of opposite over adjacent, is going to be adjacent over opposite. It's just the co-function of tan. Okay, so there is that answer, but the aim of the game with this is to go with all of the angles by using my reductions, and in grade 12 also by using your compound angle and double angle formula and apply them to manipulate all of the questions that they give here, so that you end up with something in terms of 23, so that you can read it from the sketch. Yeah, so that's the second type of question that I want to look at. We looked at the reductions, special angles we mentioned there. This also has to do with the cast diagram and reductions. And then the last thing that I just briefly quickly want to touch on is of grade 11 work is the general solution. Boys and girls, the general solution, I think most of you also know very well how to do this, but I just quickly want to mention a few things on general solution. Let me make that a negative also. With general solution, the first thing you try to do is you try to get the sine or the cos or the tan alone. So if you have a 2 there, you're going to divide by it. If I have a sine squared plus 2 sine plus 1 or something, you're going to factorize, but you try and have each factor, but in each factor you just want sine or cos or tan. You don't want sine plus tan, you want sine alone or cos alone or tan alone. And to do that, you can divide by numbers, typical solve for equations tactics, factorize. Something that you also often see quite a lot is that there's a sine and a cos in the equation, then you divide by cos so that you have tan, and then the cos over cos becomes a number. But the first step you do is you're going to get sine or cos or tan alone, right? Then after you get your sine or cos or tan alone, you get the reference angle. I just want to mention two things in general solution to you quickly. The first thing is, even if that is a negative, my reference angle, I'm going to work out by taking shift sign of the positive. Even if that's negative, doesn't matter. You're always going to get your reference angle by taking the positive ratio there. The reason for that is I want to go actually now place this. There's more than one solution to this problem. If you think of the sine graph, that continues, there's a solution there, but there's more than one solutions that will have the same value there, and I want to actually generate all of them. Now to do this, I always want to have an angle in quadrant 1 so that I can manually go and manipulate and place this in the correct quadrants. Now if you press here shift sign of -8, you see what happens. It's placing it in quadrant 4, which a negative angle lies in quadrant 4. But say I had there shift cos of a negative angle, it places it in quadrant 2. So depending on the ratio that you work with, if you type in negative things there, it will place it in other quadrants than 1. And you want to place your reference angle theta in quadrant 1 so that you can easily place it in quadrant 2 by taking 180 minus theta, in quadrant 3 by taking 180 plus theta, in quadrant 4 by taking 360 minus theta. And if your theta now lies in quadrant 4 or quadrant 2 or whatever, depending on where you placed it, it's just more challenging to place it in the correct quadrant. So always work with a positive one. This is super important, guys. Okay. The second super important thing is, if this is a complex angle there, keep it and go place it first into your quadrant. So keep it 4x plus 20, my reference angle. Don't now here go and solve for x and then place the x in the quadrants. Keep it like this, please. Otherwise you're going to get wrong answers. So I keep this 4x plus 20. I want to place this now where sine is negative in quadrant 3 and 4. So I want to place the 7, 1, 8 in quadrant 3 and quadrant 4. I'm just going to leave there space. So my complex angle, reference angle 4x plus 20, I keep like that. And then I place this angle in quadrant 3 by taking 180 plus theta, which is 7.18. That's my angle in quadrant 3, 187,18 plus k 360. I'm just going to quickly deal with this entire question before I go to quadrant 4, and now I can solve, because you see now when I jump over there, I have subtract 20, I have 167,18 plus k 360, and then divide by 4 throughout, minus 20, I have that. So this one I want to divide by 4, which is 41,795, which is going to round up to 80. So divide by 4, and don't forget that one as well. Divide 360 by 4, and it's going to go to k90. And if you already solved the x there, and you only have x, then you would still have the 360, which you see this produces something entirely different, right? So please, when you have a complex angle, keep it. First put it in the quadrant, and you place the angle in the quadrant plus k 360, and only then can you solve the x. It produces something different than if you worked out x there and place it in the quadrant. Okay, so I'm also going to place this reference angle in quadrant 4. So 4x plus 20 is equal to 7.18 in quadrant 4 is 360 minus theta, and my theta is the reference angle in quadrant 1, and then I have 352.82 352.82 plus k 360, where k is an element of set. And now I can subtract the 20, is 332.82. It's not necessary to work that out with the calculator actually, but I have the correct answer to also somewhere divide by 4, and that gives me 83.205, which rounds to 21, plus k divided by 4, 90. Right, and that is general solution. With general solution, keep two things in mind that's important. Even if you have a negative here, you work out your reference angle by using the positive, please. And then the second thing is, if you have a complex angle here, don't solve it. First place it in the quadrants and then you go solve it. Otherwise you're going to get wrong answers. Okay, so that's general solution. Course diagrams, this is everything that we did in grade 11, and then tomorrow we can work with the grade 12 formula in applying them into these things. Okay, have a good day.